kind of interesting. Now, next speaker up, Michael here, is a representative of
Sprecher Prime.
Sprecher Prime. They are a group of people that are competing in password cracking competitions. And this year at the Cracking If You Can competition in Las Vegas in August, they came in second place. And the competition runs for 48 hours approximately.
Yeah.
Yeah, 48 hours. And then there are people worldwide, all over the world, sitting at home, at school, I don't know, maybe even at work, cracking passwords. All kinds of passwords, all kinds of languages, all kinds of hashing algorithms are being used. And this is one of those competitions where it's really cool to be part of it. And it's a real challenge for anyone interested in anything that has to do with psychology, with statistics, with linguistics, with cryptography, statistics, and so on. And it's a major challenge just to be part of the competition. And Sprecher Prime, as I said, came in second this year. Now, this topic is very serious. It has to do with, well, this presentation is based on the HAshley Madison week, but of course it's related to a much bigger umbrella, a more important topic than that. And with that, I will just say good luck, Mike.
Thanks. So, okay, I start with a kitten slide, sorry. So, HAshley Madison actually used bcrypt, which is a really strong password hashing algorithm. And they used a round number of 12, which we see here. That means they have over 4,000 iterations, and that's really slow. So it's slow on CPU, it's slow on GPU. On the example of this GPU, the AMD R9 290X, it would have took, if you have four cards of these, it would have took 2 days just to attack all the 36 million hashes against one password. So it's really slow. Sure, there are FPGAs which would speed up bcrypt, but we don't have access to those. So we looked for different thing, for a different approach. One of us asked, hey, does anybody know what the loginkey is used for? It really looks like an MD5 hash. And then, okay, the source code is open, also public, then I had a look at it. I just grabbed, or used grep and searched for the loginkey, and this line popped up. When I first saw this, I really fell off my chair, because that's just a horrible thing to do. For a couple of things. Of course, MD5 shouldn't be used as at least not to hash any passwords. And the bigger thing, I think, is they lowercased the password before hashing it. So that reduces the number of possible characters by 26, because you don't have any uppercase. You don't have the possibility of any uppercase characters in it. But sadly, this line was, or I opened this PHP file, and before the login key actually got created, this was done. So what the hell is encrypt password? This is the function of it. It actually uses a class called bcrypt and hashes the password. So it's not encrypted, but anyway. So we knew that there was bcrypt, and the constructor of this bcrypt class is defaults the rounds to 12, which I showed a slide before. Then, sadly, or if you look at this, you wouldn't have any chance of getting the password out of the login key. But some of us was crazy enough to just test it and took the username, added these columns, and just a simple password like 1234, and he got the results. And I was, it can't be, because code shows it's different. HAshley Madison used Git as the version control system. So I did a Git blame and found out that encrypt password was added in the middle of June 2012. Which means all passwords were stored in plain text before. Another horrible thing to do. So, sorry. We then knew that we could attack all the login keys which were created prior to June 2012, and tried to attack them. What HAshley Madison could have resolved this issue just by creating the login keys new, because they had all the required information to do so. Also, the lower class the password, that's really, really bad. And we actually found later on there was another algorithm used to generate these login keys, and that's the second one here. The second one, which we called MD5AM2, and the first one is just MD5AM. The MD5AM2 was only used if the user updated their profile, and also only if username, password, or the email address got changed. So what we did is we have the whole login table and removed all the login keys that we can't resolve, because we have the bcrypt hash. So we have the username and we have the email address. We just generated all possible candidates for it and run them against MD5 for the login keys. So we found, or we were left with 14.4 million login keys that we can attack, where we really get the password out of it. So we mostly used MDXfind for this. That's a tool created by one of our members. And he added MD5AM and MD5AM2, and a third one that I'm going to talk about it later. Also, we used OCL hashcat to attack the MD5AM, because we could just use the username at the two columns and use that as salt, or use as an existing mode already implemented in hashcat. Also, our member, the creator of MDXfind, created a tool called PCWell, which was used to validate the bcrypt hash, because we only get the lowercase password out of the login key. So the MD5 spec AM is kind of like should say that we thought we invented a new method, but found later out that it's already been there in ages in John the Ripper, and it's it's called the single crack mode. For example, we have a username signature with the email address signature@prime@gmail.com and the password candidate prime. So what this mode does is only attack the user or only login keys that had this username and this password, and we could simply use any password candidate that we kind of guessed what the password could be. So we also had contact with the guys from Hashcat, and they implemented both of this method into OCL Hashcat, so added GPU support, and they were kind enough to give us a copy of that isn't public, but now Hashcat is open source, so you can add this yourself. At one point, when we all ran our basic dictionaries, our rules, we used another approach to crack more of these login keys. So we used something called mask modeling. It kind of looks weird, but it's kind of simple. Just look at this line. We have a length of 7. The mask is 7 digits. It is almost 4% of all the passwords in your queue are use this mask. And we had the so far cracked login keys. We only had 1.7% of it. So we calculated the delta of it. Also added the key space, all the possible combinations with this mask, and added a time in hours to find out which mask would kind of, or which mask would actually be more efficient to run against, at least at first. Later on, we used more more computation power, and attacked the masks that would took longer. We also attacked the bcrypt hashes directly. We tested, or we took all the usernames out of the database and run them against only the matching bcrypt hash. So that gave us around, or should I say it this way, around 600,000 users use their username as password. Then we had email addresses and looked at the domains and tested the already cracked passwords against the same domain. So there was HashleyMadison.com in there, amlabs.net, etc. We also took usernames and just slightly modified them and tested that against the bcrypt, and that also gave quite good results. Just remove the numbers or add some basic numbers, for example. At one point, we also tested all the top 30 login keys that are cracked login keys that we used the top 30 passwords from the login keys and run them against all the remaining bcrypt hashes we had. This still took a really long time. Luckily, some of us had free CPU power and could run this for a couple of days. So, some statistics. We cracked almost 12.3 million MD5 AM login keys. Then a bit more than 850,000 of the AM2, which means of the 14.4 million possible crackable login keys, we cracked over 90% of it. All in all, we had over 14.5 million bcrypt hashes cracked and validated. So that means that we almost cracked 40% of all the bcrypt hashes in this HAshley Madison dump. However, there were a bit more than 200,000 login keys that we couldn't verify against the bcrypt hash. To this point, we still don't know why. So if anybody has some information about that, we like to hear about it. So, of course, I'm not going to show any, I'm only going to show the top 10 passwords of each algorithm used, because we certainly don't want any passwords that could reveal a person's identity. It looks really basics. What do you see from any other leaks, except for, of course, Pussy and HAshley? That was the specific or service-specific passwords Per talked today. But there are some interesting ones in the MD5 AM2. And we believe that was used by the bots. We heard also this morning. We are not 100% sure on this. That's just a guessing, but we believe kind of strong that this is. Also, you see. Here you have default as lowercase, and the bcrypt hash is actually all uppercase. That's again because all the login keys used or were generated from the lowercase password of it. So length distribution. We were really surprised that you actually could use one character passwords. Yeah, I don't know. But the rest is kind of what you see it's kind of similar to others, to other leaks like RockQ. Also, there were only 6.4 million unique passwords of it. The password complexity. Again, most used lower case characters and numbers, or just lowercase. Numbers are also really commonly used, and then it gets more complex. But yeah, that's. So yeah, again, most of the passwords were really easy to crack, so that may not be really representing data. So yeah. Conclusions. You shouldn't just add pcrypt to your product and think you're all safe. If you really need a login key, for example, for password recovery, so you can send your users a link so they can reset their passwords. First, use random generated data and not anything from the actual user data. And maybe if it's, or not maybe, only, if it's only useful for like password reset, then let them expire of kind of after some time, let's say a day. Also, let someone look at your code, because this one was really easy to find and took me less than an hour to figure it all out. So, yeah. So, questions. And just a moment, you can contact us over Twitter and over email, and you can find an MDX find in here. So.